Hello students, this is Indrani ma'am from Sir Prasayan. In this lecture I will explain factors on which ionization enthalpy depends. The properties of element repeat after certain intervals in periodic table are called periodic properties. Ionization enthalpy is periodic property. Ionization enthalpy is denoted by this delta IH and it is always positive, means it is endothermic process, because always you have to give energy to remove an electron from the isolated gaseous atom. If energy required to remove an electron from the isolated gaseous atom in its ground state is high, then ionization enthalpy is high. If lower amount of energy is required to remove an electron from the isolated gaseous atom in its ground state, then ionization enthalpy is low. Now we will study factors on which this ionization enthalpy depends. Number 1, atomic size. Ionization enthalpy is inversely proportional to atomic size. Means if atomic size decreases, ionization enthalpy increases. If atomic size increases, ionization enthalpy decreases. So along a period in the periodic table, from left to right, atomic size decreases, so ionization enthalpy increases generally. Down the group, in the periodic table, atomic size increases, so ionization enthalpy decreases generally. But exceptions are there. Ionization enthalpy also depends on effective nuclear charge. It's denoted by Z effective. What is effective nuclear charge? It is actual nuclear charge experienced by the valence shell electrons. And it is observed that ionization enthalpy is directly proportional to effective nuclear charge. Along a period from left to right in the periodic table, effective nuclear charge increases, so ionization enthalpy increases, and down the group, effective nuclear charge decreases, so ionization enthalpy decreases. So note down this point. Now next factor is screening effect. Ionization enthalpy is inversely proportional to screening effect. Now see, for an atom, this is nucleus, this is inner shell, this is outermost shell. So inner shell electrons screens valence shell electrons from nucleus. Since S subshell is spherically symmetrical, so it has highest screening power, and P, D, F subshells are much more diffused. F subshell is more diffuse than D, D subshell is more diffuse than P. So highest screening power is there for S subshell and it is decreasing in this direction. Now see, higher is the screening effect. If screening effect is more of the inner electrons, then lower will be the attraction between nucleus and outer shell electrons. So it will be easy to remove an electron from the valence shell, so ionization enthalpy becomes low. Application of all these effects you will see in the next video, where I will explain all exceptions on ionization enthalpy. Now see, next factor, penetration power of the subshell. Ionization enthalpy is directly proportional to penetration power of the subshell. Penetration power means attraction of subshell towards nucleus. Now see, between S, P, D, F, which one is having highest penetration power? Since S subshell is closest to nucleus, it is closest to nucleus. So electrons are strongly attracted by the nucleus. So it's very difficult to remove S electrons. So penetration power of S subshell is most, and it is decreasing in this direction. So if one electron is in S subshell, due to its penetration power, it's very difficult to remove that electron and ionization enthalpy increases. So now you can say between 3S, 3P and 3D, which electron is difficult to remove? Here principal quantum number is same, n is same, n is equal to 3. So since it is closest to nucleus, therefore its penetration power is higher. So here it's difficult to remove this electron than this. Next point, half filled and fully filled subshell are more stable. So it requires more energy to remove electrons. So ionization enthalpy increases. Full filled S subshell is having 2 electrons, P is having 6 electrons, D is having 10 electrons and F is having 14 electrons. And half filled P is having 3 electrons, D is having 5 electrons, F is having 7 electrons. Next point, ionization enthalpy is proportional to oxidation state of an atom. Now see, in this example, iron is having +3 oxidation state, here +2 and here 0 oxidation state. So it is written ionization energy is directly proportional to oxidation state. Since it is having highest oxidation state, so it is having highest ionization enthalpy, then this. But why? Because here iron is having 26 protons. It is having atomic number 26. So it is having 26 electrons. Here proton is 26, but after removal of 2 electrons, number of electrons is becoming 24. Here also proton 26, but here number of electrons 26 minus 3 means 23. So since number of protons are more here than number of electrons, so attraction of nucleus is more towards valence shell electrons. Therefore, ionization enthalpy increases. In this video till this, next video all exceptions we will study. If you like, please subscribe. Thank you for watching.